Hi, Chem students. I'm going to get you set up here so you can do some conversions. This is one of the most important skills you'll learn in chemistry because it applies to any scientific field, any field at all, as a matter of fact. So this is a really good thing to get down and be really good at, so don't wait to practice this and get really proficient. So it starts like this. Scientists are especially interested in studying the properties of matter, things we can actually measure. And there's really just a few that are natural, and then there's a bunch of others that are made from those. So the properties that are natural, that are just the base units for everything, are length, charge, mass, temperature, time. There might be a couple others at the subatomic level, but in general, everything we measure starts with these units right here. And so I've given you the property and then the major unit that people use. These are the System International units that people use to represent these properties. So you need to know all of these names plus the symbols of all these things. What's confusing though sometimes is something like this. You may have seen degree C. We'll talk about that in a second, but that's a different unit, and the degree is going to be your telling point there, plus the context. If you're not talking about charge, degree C would be in temperature. So this is meters, grams, Kelvin, and seconds. Those are our main things that we'll play with in this class. And in most of your science, that's what you'll do. Add in charge when we talk about the atomic structure or electricity and magnetism in physics. There are other units that are normally created either from another scale, which we'll talk about soon, like the Celsius scale is different than the Kelvin scale, but there's a relationship between them, and that's what's important to us, and that's what we're trying to figure out how to use those today. But there's also sets of units in addition that are combinations, multiplication or divisions of other units. So an area is just length times length, so it's going to be meters times meters and meters squared. We're used to, in the United States, using feet squared. So, square feet. That's the common methodology here in the United States, but the rest of the world uses meters squared. Velocity, in our car, it's miles per hour. That's our speed, which is also kind of like velocity. But in science, we tend to use meters per second. So it's a length divided by time, as you see. And then here's another one, density, which is just the mass divided by the volume. And the volume itself is really, normally the volume is going to be length times length times length, or length times width times height. But they're all units of length. And if we think about that, then there must be a traditional unit called a liter that's out there. And this guy right here is a milliliter. And at the end, we'll talk about the metric system and how the milli, what that tells us about the liter. So the whole idea is that we've got all these ways of measuring things and expressing them. We need to make sure that when we talk about them, we talk about them the same way. Because if you go and measure something with inches and I measure it with centimeters, we're going to get different answers. So let's take a look. We're talking about the idea of different scales. So the same object, no matter what it is, so if I was to draw just an object here, as I do that, the length of this object, if I draw a line straight up, in inches I'm getting 2, almost 3 inches, but I'm over 7 centimeters if you look at this ruler that I've got here. So the object is the same length, it's just how we talk about it is different. And it's just like me doing this, and you look at that, you go, oh, that's a blue dot, or the word blue and dot. They're the same thing, okay, in the sense of what they describe, but they're just a different way of representing them. So what we have here is the issue of sometimes there'll be different scales, and we'll need to convert from one scale to the other, and other times we're just going to have to convert from one type of quantity to another, which, if you just remember earlier, I talked about density. That was in grams per milliliter. That's a mass per volume. So mass per volume, that's two different types of things. One's a property of matter in its own right, and the other's another property of matter in its own right. But there's a direct relationship that has been able to be determined for a substance about this thing called density. So lastly, here's some relationships you should know. These are defined, and defined relationships means essentially that they have an infinite number of sig figs. So whenever you use any of these that you see on the left, those will not have any bearing whatsoever on the significant digits of your measurements. So if you have 12 inches is equal to 1 foot, it's a definition. It's not 12.0, it's not 12.00, it's 12 point with an infinite number of zeros equals 1 point, an infinite number of zeros, feet. So that'll never be the problem for you, in that these things will interfere with significant digits. You need to know all of these right here, and then I'm starting you off with just a few of the metric system. I want to just point out that when I put the little X here, that can be any unit. It doesn't matter what the unit is. It can be feet, it could be, you never hear anyone say centifeet, but seriously, that's an acceptable thing to do, because the metric system applies to any unit, and it just chops things up into units of 10. And these are the first ones I want you to know. I want you to know that when you hear the word centi, that means it's been chopped up into small pieces, and that there's 100 of them. So this one unit, X, has been chopped up into 100 little pieces. Each one of those little pieces is called a centi-X. So a centimeter is 1/100th of a meter. Same thing with a millimeter or a milligram. A milligram is 1/1000th of a gram. So you need to memorize these relationships kind of as you see them here, and a few more that we'll do that are important for scientists as time goes on. So this is a great start for us. The next thing we need to learn how to do is use this information, these relationships that we've just figured out, and turn them into some kind of way to do mathematical conversions. So that's up next in the next video.